Hello everyone, my name is Dana and I'm from the Bodhi Academy. So today we'll start with the new chapter of Standard 11th, that is structure of atom. So as we know, atom is the fundamental unit of any matter. Any matter which is made up of atoms. So this was given by the early Indian and Greek philosophers. So what they said is that atoms are the fundamental building blocks of any matter. Okay, and they continued to tell that subdivisions of matter would ultimately yield atoms. So if any atom it is divided continuously, at the end what we get the particles, those are atoms. So this is what they said. So ultimately yield atoms which will not be further divisible. Further divisible means which we cannot divide them further. So the word atom, it is arrived from the word Greek that is atomio, and the meaning of this word is uncuttable or non-divisible, which means it cannot be broken down further. So these earlier ideas were mere speculations and there were no way to test them experimentally. So all these things that atoms are the ultimate product of any matter once they are divided. So these are all just speculations. Speculations means all the theoretical thing. They didn't prove it experimentally. Nowadays, if we are telling anything, we have to prove it experimentally, right? So these things were not proved experimentally. They were just a speculations. So these ideas remained dormant for very long time and were revived again by scientists in the 19th century. So these theories, they were just kept like that only. And later in 19th century, scientists had made various discoveries, various experiments to prove this theory. So one among them is that the atomic theory. So what is the atomic theory of matter was first proposed on the firm scientific basis by John Dalton. So John Dalton, he was the first one to propose the atomic theory. His theory is known as Dalton's atomic theory. You all must have heard about this in your lower classes as well as in a previous chapter also we have seen about the Dalton's atomic theory. So what we are going to do in this chapter is we'll start with the experimental observations made by scientists towards the end of the 19th and beginning of the 20th century. So now we know that earlier times they have made a statement that all the matters are made up of atoms, right? And we don't know if whether that statement is true or not. Later in 19th century, scientists has came up with various experimental views proving that it is made up of atoms. So in this chapter, we'll see the experimental works done by and what are the observations they have got in the early end of 19th century and early beginning of the 20th century. So this established that atoms can be further divided into subatomic particles. So initially what they have said ki matters are divided into atoms, right? And they said that atoms are the final part. It cannot be further dividable. But later in 19th century, scientists had discovered that this atom can be further divided into subatomic particles. Okay, they said that these atoms can be further divided into subatomic particles. For example, these subatomic particles are electrons, protons, and neutrons. So a concept very different from that of Dalton. So what Dalton said is only about the atoms, but apart from atoms, it can also be further divided into subatomic particles, which are electrons, protons, and neutrons, which is completely different from what Dalton had said. So the major problems before the scientists at that time were. So what were the problems that were faced by the scientists at that time? Like to account for the stability of atom after the discovery of subatomic particles. So once the scientists earlier they have only discovered about the atoms, right? No one had discovered about subatomic particles, so they were only focusing on atoms. But later when the other scientists came up with these subatomic particles, it was difficult to stabilize the theories regarding the atoms because there is something like subatomic particles are involving now, right? So to compare the behavior of one element from the other in terms of both physical and chemical properties. So now they have subatomic particles. Atoms, we can directly compare them. But when there is subatomic particles, it is difficult to compare one element to other element with regards to their physical and chemical properties. To explain the formation of different kinds of molecules by combination of different atoms. Now you know why a bond is formed, because there are electrons present to form a bond. Now, initially, when the subatomic particles were not formed, that time they didn't know that there are electrons which are helping to form this bond. They just said it is formed to make a stable compound. What is that which is forming this bond was not discovered. So later it was to explain the formation of different kinds of molecules by the combination of different atoms. So this was difficult because they only know about atoms. They don't know about subatoms, right? Because electron is a subatomic particle. Since they don't know subatomic particles were existing, they only had known about the atoms. So atoms cannot directly form any bond, right? So it was difficult to explain how this bond was formed, only with regards to the atomic theory. To understand the origin and nature of the characteristic of electromagnetic radiations absorbed and emitted by atoms. Now, whenever a molecule absorbs any energy or it emits energy, there are electrons which are coming in and going out. So with respect to atomic theory, we can't explain how an energy is absorbed or energy is emitted, because their electron is involved. Electron is a subatomic particle, right? So since atomic theory doesn't mention anything about the subatomic particles, it was very difficult to explain the bond formation and the electromagnetic radiations which are absorbed and emitted by an atom, how they are absorbed, how they are emitted, what is the thing that is absorbed, what is the thing that is emitted. These were very difficult to explain. So unless and until subatomic particles were involved, there is no bond formation or emission or absorption of any kind of energy is involved. So these were the things which were not been able to explain by the atomic theory which was given by Dalton. That's why his theory was eventually ruled out. So the subatomic particles. Now we'll see about the subatomic particles. Now what are subatomic particles? So Dalton's theory was able to explain. Now what are the things that Dalton's theory explained? It can explain the law of conservation of mass. So what is the law of conservation of mass? It states that an atom can neither be created nor destroyed. That was the law of conservation of mass. Then we had law of constant proportion, constant composition. So what is law of constant composition? Every molecule will have a constant amount of atoms in it. Now for example, H2O. H2O will not change. The amount of hydrogen and the amount of oxygen will remain same. That is constant composition. It won't change in any condition, right? Then law of multiple proportion. Hmm? So all these laws can be successfully explained by the Dalton's atomic theory. However, it failed to explain the results of many experiments. For example, if I say it was known that substances like glass or ebonite, when rubbed with silk or fur, generate electricity. Now, you know, if you take a glass, okay, and you rub it on any silk or a fur, means if you rub it with your hair, on your hair and you place it on a paper, the paper will stick to the glass, right? So it generates electricity. Or if you rub it constantly on your dress, take a mirror, rub it constantly on your dress, and then hold it against your hair. Your hair will stand. So that means that rubbing glass or ebonite, ebonite is also a form of transparent material, when rubbed with silk or fur, generate electricity. So this was not able to explain by the Dalton's atomic theory. So many different kinds of subatomic particles were discovered in the 20th century. So in the 20th century, many different kinds of subatomic particles were discovered. However, in this section, we will talk about only two particles, namely electron and proton. So in this section, we will only discuss about the electrons and protons, which are the important ones. So, discovery of electron. Who discovered electrons? So, in 1830, Michael Faraday showed that if electricity is passed through a solution of an electrolyte, chemical reaction occurred at the electrodes, which resulted in the liberation and deposition of matter at the electrodes. Now, Michael Faraday, he is the scientist. He conducted an experiment showing that when an electricity is passed through a solution, if we take two beakers, okay, both containing chemical solution, electrodes, both are connected through using a bridge. A connecting bridge is used, and these electrodes are connected to battery and to each other. Okay, when an electrolyte, so this will contain particles, those are known as electrolytes. So chemical reaction occurred at the electrodes. So these are electrodes which is resulted in the liberation and deposition of matter at the electrodes. So what happens when electricity is passed through this electrodes? This particles from this solution will travel through the circuit and reach the other electrode, and it will get deposited to this electrode. Similar thing will happen when the particles from this side travels back here. So there is deposition of molecules or electrons on the electrodes. So there is something which is deposited or which sticks with the electrode. He formulated certain laws which we'll study in class 12. So there are certain laws of Michael Faraday which you will study in your higher classes. So these results suggested the particulate nature of electricity. So what is particulate nature of electricity? That means electricity can be passed through a small particles. So an insight into the structure of atom was obtained from the experiments on electrical discharge through gases. So the structure of atom was obtained from the experiments that were carried out on electrical discharge through gases. So how electricity is passed through gases. During these experiments, the structure of atom was obtained. So before we discuss these results, need to keep in mind a basic rule regarding the behavior of charged particles. So we'll discuss about them, but you have to keep one thing in your mind, that is regarding the behavior of charged particle. Like charges repel each other and unlike charges attract each other. So you have to remember this throughout your entire life if you are someone who are interested in chemistry. So this is very important. That is, like charges repel each other and unlike charges attract each other. Okay. This is the behavior of charged particles. So in mid-1850s, many scientists, mainly Faraday, began to study electrical discharge. So in partially evacuated tubes known as cathode ray discharge tubes. So I'll show you what is a cathode ray discharge tube. So this is a cathode ray discharge tube, which is a partially evacuated. Evacuated means it has an opening. So it is depicted. So here it is depicted. This is the, you can see actual thing. This is the cathode ray discharge tube. Okay. There here is the vacuum pump fitting. So it is evacuated. So a cathode ray tube is made of glass containing two thin pieces of metal called electrodes sealed in it. Now these are the electrodes. Both of them, this and this. Both of them are electrodes. So these are the electrodes. Now electrodes are of two charges, cathode and anode. Okay. So the electrical discharge through the gases could be observed only at very low pressure and at a very high voltage. So the pressure difference The pressure of different gases could be adjusted by evacuation. When sufficiently high voltage is applied across the electrodes, current starts flowing through a stream of particles moving in the tube from negative electrode to the positive electrode. Now, what will happen is these electrodes are placed inside this tube. This is a vacuum tube, nothing is there inside. So, there are two electrodes placed in them. One is cathode, other one is anode. Okay, these are the two electrodes. So, the electrical discharge through the gases could be observed only at very low pressure and at very high voltage. So, if we pass electricity through this, it can be only observed when there is very low pressure and a very high voltage. If we apply high voltage and low pressure, we can observe the movement of, or at that particular time only the electricity will be discharged or generated. The pressure of different gases could be adjusted by evacuation. When sufficiently high voltage is applied across the electrodes, current starts flowing through stream of particles moving in the tube from negative electrode to the positive electrode. Now, the pressure is created by the gas present in them. Okay. Now, this experiment is the one where we can identify the structure of atom. I told you, the structure of atom was obtained by the experiments carried out on the electrical discharge of through gases. So when there is, so here the gases are involved. So the pressure of gas and the high voltage will lead to the generation of electricity. Now, we require very low pressure. So the pressure of gas is maintained by the evacuation or through the vacuum pump. So whenever there is high pressure, through vacuum we remove the pressure and maintain it to the low pressure or the required pressure for the electrical discharge. So once the pressure and high voltage is applied, you can see the stream of particles or the particles moving from the cathode to anode. Cathode is the negative electrode and anode is the positive electrode. So you can see electric particles moving from cathode to anode in this direction. Okay, these were called as cathode rays or cathode particles. Now the particles which are moving from cathode to anode, they are known as cathode ray particles, or it is known as cathode rays because they are coming from the cathode. So the flow of current from cathode to anode was further checked by making a hole in the anode and coating the tube behind anode with phosphorescent material zinc sulfide. When these rays are after passing through anode strike the zinc sulfide coating, a bright spot on the coating is developed. Now, I just said that the particles will move from cathode to anode. Now, how you will know that already the particles have been moved from cathode to anode? Because atoms are so small that we cannot see through our naked eyes. So, to confirm that small particles have moved from cathode to anode, what we do is on the anode side, we make a small hole and we apply zinc sulfide to it. A zinc sulfide is applied. Zinc sulfide is a phosphorescent material. Phosphorescent material means it is a shiny material. So when a particle moves from cathode to anode, when it reaches the anode and it enters the anode section and it strikes at the zinc sulfide point, it leaves a bright spot on it. So whenever a particle comes and strikes on the zinc sulfide or the fluorescent coating, it will leave a bright spot. And this bright spot will indicate that the particle has been moved from cathode to anode. That's how the experimental work was observed. Or now they just said theoretically that these things are happening. That is, particle will move from cathode to anode. Now we need an experimental proof, like they have successfully moved from cathode to anode. Now, this is how they proved that the particle has moved from cathode to anode by showing it on the zinc sulfide coating. Okay. So the results of this experiment, what were the results of this experiment just carried out is the cathode rays start from cathode and move towards anode. First thing, the particle will start from cathode and it will move to anode. These rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials. As I told you, we cannot see these rays passing through the tube, right? But we can confirm they have passed through by applying certain materials on the anode side, which glow when it hits by them. So this will glow whenever a particle will come and hit on the surface, which will confirm that the particles are moving. So television picture tubes are cathode ray tubes, and television picture results due to fluorescence on the television screen coated with the certain fluorescent or phosphorescent material. Now the television which we observe, it also has this cathode ray discharge tube. Now what happens? The cathode will continuously emit the particles or the rays which will be reflected on the anode surface, that is our TV surface, which is already coated with a fluorescent material, and that's why we can see the images on the television. Second, in the absence of electrical or magnetic field, these rays travel in straight lines. So if there is no electrical or magnetic field, the rays will pass in a straight line. Okay. Now what will happen when electrical or magnetic field is applied? We'll see later. Okay. So without any electrical or magnetic field, the light will or the rays will travel straight. So in the presence of electrical or magnetic field, the behavior of cathode rays are similar to that expected from the negatively charged particles. So in the presence of electrical or magnetic field, the behavior of cathode rays are similar to that expected from a negatively charged particles. So suggesting that the cathode rays consist of negatively charged particles called electrons. So what they said is whenever there is an electrical or magnetic field, now without them they move in a straight line, right? So when there is an electrical or magnetic field, the behavior of cathode rays are similar to that expected from a negatively charged particle. So it will behave similarly like a negatively charged particle. Due to this, the term electron was involved or discovered since a negatively charged particle, suggesting that the cathode rays consist of negatively charged particle called electrons. So they considered that cathode rays, they consist of a negatively charged particle called electrons. So the characteristic of cathode rays, that is electrons, do not depend upon the material of electrodes and the nature of the gas present in the cathode ray tube. This is very important, as the characteristics of this cathode rays or the electrons, they do not depend on the material of electrode which is used or the gas present in the cathode tube. Thus, we can conclude that electrons are basic constituents of all atoms. So hence, it was said that electrons are the basic constituents of all atoms. Okay. So now in today's class, what we have seen is we have seen about the subatomic particles and discovery of electrons. So who discovered electron? Electron was discovered by Michael Faraday. So in our next class, we will see about the charge to mass ratio of electrons, charge on the electrons, and charge on the electrons. Okay. So thank you for watching my video. Please do like, share and subscribe to our channel.